Aerospace, Boeing and Kaplan Astronautics, Michael Business and Product Development in Space and Robotic Science Missions. He's currently Director of NASA Business Development at SSL. And then Dan Eisenstein is a Professor of Astronomy at Harvard University. I've known Dan since, well, he was an undergraduate and was my senior thesis student here. And Dan has gone on to play a leading role in a number of areas of astrophysics. Best known for his work with the Sloan Digital Sky Survey and for developing the use of baryon acoustic oscillations, a ruler that is now the standard tool for measuring the size and shape of the universe. He was been elected to the National Academy of Sciences, was awarded the 2014 Shaw Prize in Astronomy, and 2016 was selected as a Simons investigator. And then we fortunately had known that he was going to join us and then had to drop out and then rejoined us this morning. Ken Chang, who's a reporter with the New York Times, and you were a member of the class of 87. So he represents the youth end of the panel. Though, actually, Dan's younger. Dan's 92. But now one of the things that being back for my 35th, I remember when I looked at the classes coming back for the 25th and thought, boy, they're old. With time, your perspective changes. So recently, I was part of organizing a panel in Washington for the National Academy, looking at the future of civil space as we going through a transition to a new administration. It's a good time to think about where we're going. And when we began the panel, General Les Lyles, who's now head of the NASA Advisory Council, began by noting that this is probably, at least since the 60s, the most exciting time in the U.S. civil space program. And it's an excitement generated by activities really all across civil space. Civil space is more international than ever. We used to have just a handful of countries that participated with civil space programs, and now places like India, certainly China, have become major players in space exploration. On the commercial side, we have many new entrants into space launch and space satellite business, and bringing with them lots of innovation. We're on the verge of starting to send humans towards Mars. And within space science, as you'll hear with missions like JWST on the way, we now have orbiting some remarkable telescopes and have some really powerful instruments coming in the next couple of years. So this is just a tremendously exciting time. And my hope is that this panel conveys, I think, the sense of excitement that all of us feel about the possibilities in space. So I'm going to ask each of the panelists to say something about what excites them about what's going on in space now. So let me begin with Katherine.
So the thing that excited me most since I've been a child is human spaceflight. Since the space shuttle retired in 2011, we've had no domestic route to get humans into space. And so all of our astronauts on the International Space Station, on the ISS, get there via the Russian vehicle, the Soyuz. So clearly we need, and NASA's goal is to get people back into space with some domestic vehicle. NASA has a grand plan, and their next step is to build a behemoth rocket called the SLS, the Space Launch System. And that one's going to launch the crewed capsule Orion, which is a leftover from the Constellation program from about 9 years ago, they've kept in development. And NASA's goal is to take that to the moon and establish a semi-permanent habitat there and then go to Mars. The plan for the moon, they're calling it the Deep Space Gateway. It's meant to be fairly small, much smaller than ISS, habitat, a space station in cislunar space between the Earth and the Moon, possibly around the Moon. And that is meant to be a test bed for deep space technologies that we need to live in deep space for an extended period of time. It's different than being in Earth orbit. Psychologically, it's different. You're much farther from home. Radiation environment is very different, much more damaging. So it's different to have people away from Earth for extended periods of time. But we need to get used to that if we're going to go to Mars. It takes a very long time to get to Mars and get back from Mars. And then I think in the area of the Deep Space Gateway, NASA wants to assemble the Mars vehicle that they're calling the Deep Space Transport. So that will be launched in pieces, assembled in pieces, I think facilitated by the people that are staying on the Deep Space Gateway station. And that will be NASA's Mars vehicle. So that's NASA's vision. But the really cool thing is that NASA's not the only one who's sending people into space. We're not the only one that plans to send people into space anymore. It's no longer the realm of big governments. It's not just China and Russia and the US that can send people. Private companies are getting involved in a way that they never have before. And there's sort of two routes to doing this. One route is working very closely with NASA in what we call public-private partnerships. And the other route is going it alone with private money. So there are a lot of companies that are participating in these public-private partnerships, which is where NASA, or it could be another government organization, could be the Air Force or something, puts up some portion of money for the development of a new technology. It might be a launcher, it might be a crewed vehicle, or it could be some high-tech component that goes on a vehicle or on a spacecraft. So NASA puts up some of the funding, but the company pays for a good bit of it too, of the development cost. So then once the component is developed, the government can buy it, but the company can also sell it. So it's sort of everybody wins. The government gets the technology that they want, but the company gets help developing it, and then it continues to foster an economy, a space economy, which I think is important to continue to try and develop. So there are a couple of big public-private partnerships going on right now for crewed flight. The first is the ISS Cargo Resupply Program, and then there's a commercial crew program. So ISS Resupply, while we haven't been putting people up to the ISS, we have been sending them stuff. So they need food and water and clothing and scientific instruments. So NASA had partnered with my company, Orbital-ATK, and SpaceX a few years ago to develop a cargo capsule to go up to ISS. So Orbital developed our Antares launch vehicle and our Cygnus cargo module as part of this public-private partnership with NASA, and have flown several flights up to supply space station. And SpaceX is doing the same thing with the Dragon capsule on their Falcon 9. And then the other major public-private partnership in crewed flight is the commercial crew program. So that's been split between Boeing and SpaceX, again with NASA. And their goal is to get people to the space station, so people into low Earth orbit, which, as I said, we haven't done since 2011. And so Boeing has a manned capsule that they're going to fly on Atlas V. SpaceX has a manned version of their crew capsule, of their Dragon capsule, that they're going to fly on Falcon 9. And so they're, last time I checked, they're expecting to launch 2018, 2019 timeframe, so fairly soon. So we'll hopefully be back in orbit soon, domestically. So that's all very exciting. And then the very new piece of it is the privately funded part that is largely independent of NASA or government oversight or funding at all. And so these companies, the big ones are SpaceX again, Blue Origin, Virgin Galactic. They're backed by billionaires. Most of them are backed by billionaires with millions in venture capital money. And the cool thing that they want to do is they want to send private citizens, so normal people. If you consider, someone that can spend $200,000 on a ticket, a normal person. They want to send private citizens, not NASA astronauts, to space. So that's really exciting. There's never been a prospect for a normal person to go into space until recently. So SpaceX has a very grand plan. If you're interested, Elon did a talk, Elon Musk, the CEO of SpaceX, CEO, and he calls himself chief engineer, did a talk at a conference a couple months ago where he laid out his grand plan for Mars exploration. It's pretty interesting. It's rather grandiose, but find it on YouTube. It's interesting to watch. It's an hour long, so commit yourself to it. But so Virgin Galactic wants to send people on suborbital flights. So that's sort of the space tourism thing that you hear about. They're going to shoot you up and bring you back down. You won't go into orbit, but you'll be weightless for a few minutes and have a pretty spectacular view. And then Blue Origin, I think their intention is to do Earth orbit and maybe deep space along with SpaceX. All these companies, and there are many others that are doing smaller things, small launchers, habitat technologies like Bigelow Aerospace, inflatable habitats. Lots of other people are getting in the game. And the big ones have all met some pretty significant milestones, have created a lot of really exciting new technologies, have done a lot of testing. It seems highly likely to me that somebody private is going to get people into space sometime in the next decade or two. So that to me is very exciting.
Okay. Well, let me first thank you all for coming at this beautiful hour in the morning through the rain. It's nice to see some happy faces out there. I'm going to talk about robotic exploration of the planets. And I'm going to start by talking about what many people call the golden age of exploration. And that's back in the 70s. At that particular point in time, there was a mission called Mariner 10 actually, that went and visited Mercury, went by Venus, and used the gravity assist from Venus to propel it on to Mercury. That was the first time that happened, and it gave us a view of the Mercury planet. Meanwhile, at Venus, the Soviets were soft landing, and they did that successfully several times during the 70s. If we go on and we go to Mars, the U.S. put Mariner 9 around the planet, and it was the first time that we really had an orbiter around Mars, and we were able to see that the planet, in fact, was not a desiccated moon-like being. It was something that looked like it had water flowing at some point in time. We followed that up with two Vikings that actually soft landed successfully, and it gave us our first real touch of the soil at Mars. We also developed the Voyagers, which did the grand tour, and they went through the planets of Jupiter, Saturn, Uranus, and Neptune, and showed us what those planets could do. So it was a terrific decade. So, like many people call it the golden age, I would say that right now we're in the platinum age. It's amazing what we've done from 2015 all the way out to 2025. If you think about it, you start, first of all, let's start with the inner planet Mercury. Messenger was there, just finished up its mission, its 5-year mission, and it was actually orbiting Mercury, which is a very difficult thing to do. It found the temperatures on the sunlit side of 800 degrees Fahrenheit, and on the shaded side, it was about minus 250 degrees Fahrenheit. Remarkably hot planet on the sun side. But it's not the hottest planet going. The hottest planet in the solar system is really Venus, about 860 degrees Fahrenheit. And there's an orbiter around that right now that comes from Japan, looking at the atmosphere. We skip Earth and Mars just for a second, and we go on. The next thing we hit going out from the sun is the asteroid belt. And there's an awful lot going on there. Right now we have a mission called Dawn, which is out there, and it actually went and it's orbited Vesta, which is a major asteroid, and it's now orbiting Ceres. That takes a lot of energy to be able to do that. You've got to be able to get into orbit and get out of orbit. And to do that, you need a special propulsion system called electric propulsion. And a lot of that was developed here, right here at Princeton, under Bob John and his laboratory. And that spawned a whole U.S. contingent that developed electric propulsion, which is really enabling many of these missions today. Other missions that are going out there, OSIRIS-REx has been launched. It's going to go, and it's actually going to touch and drag like a rope-like structure across the asteroid and bring back pieces of an asteroid to us. That's been launched and it's in flight now. If you think about it, in 2015, it was a remarkable year also for the European Space Agency. They went and they actually rendezvoused with a comet, and they actually put a soft lander about the size of a washing machine down on that comet. Fantastic mission. Then if we can keep moving out, you get into Jupiter. Right now we have Juno, which is orbiting Jupiter and looking at the atmospheric composition and dynamics, and it's trying to tell us about the origin, what made Jupiter the planet that it is. In addition, we've actually started on the next flagship mission, which is the Europa Clipper. We are going to go to one of the moons of Jupiter, one of the very special moons. It has an ocean, and where there's water, there might be the chance for life. So we're going to go there. We're not going to. We have a mission to actually orbit Europa, and there may even be a lander that goes with it. And it's going to be fantastic. That'll probably be launched in 2022, 2023. If we continue to go out, go to Saturn, we have Cassini. Cassini was launched in '97. It's been up there for 20 years. It's been orbiting Saturn for the last 15, and it has told us about the planet, it's told us about the rings, and it's told us about, again, ocean moons that are there, Titan and Enceladus, both of which are very Earth-like in many ways. Titan actually looks like a prototype Earth, what Earth was like in the very early portions of its existence. And Enceladus is another ocean moon in that there's a crust of ice on the outside with water ice, water underneath. And again, it's a very fascinating moon to look at. We didn't go to Uranus, we didn't go to Neptune, but we did go to Pluto. We flew by Pluto and Charon, and we got to look at these objects out in the Kepler belt. And that mission, New Horizons, is now going to another object out in the Kepler belt. We keep exploring more and more. But that's not it. I'm going to come back to Voyager. 40 years ago, we launched Voyager, and it's still out there, and it's actually left the solar system now. It's left the influence of the sun, and it's in the interstellar medium. And it's sending us back information, telling us what's out there and what it sees. It's been a fantastic time for all the planetary investigations that are going on. But let me come back and talk about Mars for a second, if I can. Right now, we have a very intensive investigation of Mars. We have 6 orbiters from this world orbiting Mars. 3 from the United States, 2 from the European Space Agency, and 1 from India. And all of them are looking at different aspects of the planet and bringing us back information. We started a continuous observation from space at Mars back in 1996. So it's been almost 20 years that we've been following and looking at the planet. In 2004, we landed both Spirit and Opportunity, 2 rovers on the planet, and then we followed that up with Curiosity. So we've had 13 years of continuous observations from the surface of Mars. All of them together are working to give us an insight of what the planet is like. The rovers are our geologists that are on the ground and looking up close and personal at the soil, and then our orbiters are taking that knowledge and are able to apply it over the entire planet. So it's a fantastic mission. I'd say that we have 1 more rover that we're developing. That's 2020, and that will use the same kind of equipment that we used on Curiosity to land. And that will actually not only take new science instruments, but it's actually going to take samples and put them in containers and then leave the containers on the surface for potentially another mission to come along, grab those containers, and bring them back to Earth. So it's a very, very exciting time in planetary exploration right now. So, thank you.
In the commercial space, actually, there's a lot of activity that overlaps with activities in the government as well, in this public-private partnership model that Katherine described earlier. So when I look at the commercial world, I see a couple of technologies that are evolving that can be real game changers. And then what's even more exciting is you think about integrating these things and get an idea of what's to come in the future. The first has been a trend that's gone on, I guess, for the last, 6, 7, 8 years, and that's the launch industry. Traditionally, in fact, a lot of people here in the space business use terms, if you've heard them, old space and new space. Old space refers to the connotation of large government programs with companies like Boeing and Lockheed Martin involved, and they've built the majority of the launch vehicles that have taken satellites and humans for the U.S. into orbit. And typically, when you look at launch costs, you use a metric of dollars per pound to geostationary orbit. So using old space technology, shuttle and atlases and deltas, typically the costs are around 25,000 pounds to take anything to orbit, whether it's a block of lead, a stack of paper, electronics box, whatever. The new space world that we're in now, there's many, many companies, but maybe among the most prominent ones are SpaceX, Orbital-ATK with the Antares vehicle. Costs have come down enormously. And when we look at the history of technology and commercialization of technology, developing products, things happen when costs drop enormously. So right now, launch costs using Falcon 9, for example, it's more than a factor of 10 cheaper. And so what that means is when you reduce launch costs by that much, people that are developing ideas for new businesses in space, whether it's remote sensing, communications, tourism, whatever, business models start to close that wouldn't close otherwise with higher launch costs. So, I think, and with, for example, if we focus at Falcon 9 with what SpaceX is doing, right now we're seeing that they're beginning to reuse the first stage of the launch vehicle. But Elon Musk has announced that his intention is to basically try to reuse all parts of the vehicle, the launch fairing, the upper stage. So the more of the vehicle you can reuse, the lower the costs will be that they can charge and turn it into a profitable business. That, in fact, drives the development of other businesses, many of which we haven't seen yet, but there are a lot of people that are working this right now. And as you'll see over the next couple of years, many new companies are going to be announced that are going to provide new products and services that we couldn't even thought of before. So launch is one real big trend, costs coming down. The other is satellite servicing. Now, we've dabbled with satellite servicing. We were all thrilled and amazed watching the several Hubble Space Telescope servicing missions. And in fact, if Hubble wasn't serviced, people like my colleague Dave and astronomer Daniel over here would be kind of looking at the universe with a very fuzzy image telescope. Hubble was launched with a perfectly shaped mirror, but perfectly shaped in the wrong prescription. So a servicing mission was announced, and basically an instrument was put on board to correct the optical system. This was done largely by humans. It was largely a human servicing activity. However, it did have what we call robotic support. The robotic arm, Canada arm on the shuttle, provided support for the astronaut, maneuver the astronaut around so the astronaut could go off and do the repairs. And several other missions afterwards put in new cameras and better instruments, just made Hubble a much better, more powerful observatory over time. So we've had some experience with human servicing and human construction. But what's been happening lately is now we're seeing the world of fully autonomous robotic servicing. The first demonstration of this occurred back in 2007, the mission called Orbital Express. It was a joint DARPA, Boeing, and NASA experiment, which demonstrated the ability to refuel the satellite in orbit, swap out electronics boards, and do some simple repairs in addition. So that mission was highly successful. I was at Boeing at the time. We were all real excited and thought it was going to kick off a new business in satellite servicing. The problem is that Boeing also makes a whole lot of money selling new satellites. So, I was in these interesting meetings in which we were saying, "Wow, now let's go commercialize this demonstration. Let's go fix satellites." And the VPGM of our commercial space was, "Wait a minute, we'll make way more money selling new ones than you'll ever make on these repair jobs that you propose to do." So it was kind of shelved for a while. So great idea, wrong time. So now we come into the era now where satellite costs have come down. It's much more competitive, many more players in the market. So now all of a sudden the economics change. So recently, in the last 6-7 months or so, there have been 2 public-private partnerships launched. One from NASA Goddard. There's a mission called Restore-L, and it's a demonstration of refueling Landsat 7. It's an Earth-orbiting Earth observations satellite. It's supported NOAA and weather observations for the weather program. It's an end of life, so we're going to try to refuel it to demonstrate refueling a satellite that was not designed to be refueled. These other things that we did earlier, Hubble was designed to be serviced, and the Orbital Express mission was servicing a satellite that was designed to be serviced, but this is another challenge because you got to bring all kinds of other special tools along, and there's no humans involved. This will be completely autonomous. So that mission will probably fly around 2020, 2021, and another mission that's going to be in low Earth orbit, and then in geostationary orbit. Recently, DARPA and Space Systems Loral announced a partnership for a mission called RSGS, Robotic Geostationary Servicing Demonstration. I think that's what the acronym stands for. And this will be to demonstrate refueling, servicing, close-up inspection, also moving the satellite around, because in the commercial geocom business, you can have a viable business providing telecom services to a certain area, and then the business can change. And what that would mean if you had the capability would be to move your satellite to another orbital slot, another longitude slot, and the capability doesn't exist to do that now. So this type of capability will soon be demonstrated. That's going to fly around 2021 as well. And the last piece of interesting technology that's developing is something that Jim mentioned earlier, solar electric propulsion, because what this technology does, it enables, it's much, much more efficient to go from point A to point B in space. So when you glue these things together, what I think is we're going to see a revolution of new industries emerge that'll be very exciting. And the one that excites me the most, it's probably at least 10, 15 years off, but there are several companies now that are talking about extraterrestrial resource mining, extraction, deep space industries, planetary resources, and the way they're going to be able to succeed with their businesses is if you think of gluing together SEP technology with advanced robotic servicing technology and low cost launch. Those are all 3 key pieces that companies like DSI and Planetary Resources need. So it might not be in the too far off in the distant future that products that we buy here on Earth will in fact come from asteroids. So to me, I find that very exciting.
Okay, so I just want to echo thanks for everybody to get up and hear us this morning. So I'm an astrophysicist. I'm really working on the application end of what's been talked about. I primarily work in cosmology and extragalactic astronomy, and I do so with a variety of ground-based telescopes and space-based telescopes. But in the spirit of this session, I wanted to focus on one upcoming major event in space astronomy, namely the arrival of the James Webb Space Telescope. So James Webb is the successor to the Hubble Space Telescope, and it's going to be the flagship mission in astronomy for the next decade. It's going to be launched at the end of 2018, so we're about 15 months away from the scheduled launch date. And I only have a small role in the project. I'm a member of the science team of one of the 4 instruments. But it's going to be so transformative for wide areas of astronomy that I wanted to share some of the important aspects of it with you to get you some flavor of how the technologies of space telescopes can interface with the science goals. So the most obvious thing, there's a picture there, yes. So the most obvious thing about James Webb is that it's a big telescope. So the Hubble Space Telescope, of course, had a tremendous mission. The primary mirror of the Hubble Space Telescope is about 8 feet across. So it's about the size of one of these chalkboard panels. And the James Webb Space Telescope is 6.5 meters across. So a little about 22 feet across. So it's basically like the size of the picture up at the top of the panel. So it's a big increase in collecting area. And whereas the Hubble Space Telescope has operated primarily in visible light and also a little bit into the ultraviolet, a little bit into the infrared out to 2 microns, James Webb will actually be focusing towards longer wavelengths. It will start with about the reddest light that you can see and go out to about 25 microns, with a particular focus at the range of 1 to 5 microns. So this is going to be a tremendous opportunity for the study of early galaxies, particularly the critical early phases of galaxy formation, just a few billion years after the Big Bang. And why that's so important for us is that that's really the way that we get to see how the story of galaxy evolution gets started, there's so much of the story gets set up in those early times. So James Webb is looking further into the infrared, and why is that so important? So our eyes work in what's called the optical bands, wavelengths around half a micron. And this is a great place to study stars because stars have a temperature that causes them to glow and emit most of their light in the optical or perhaps a little bit bluer into the ultraviolet. And there's lots of well-studied diagnostics of stellar populations that emit their light in that range. But because the universe is expanding, the light as it travels to us from those early galaxies actually has its wavelength stretched. And so the diagnostics that we're used to studying in the optical, when we look at them from early galaxies, have had their wavelengths stretched by factors of 4 and even 10. And so all that light has gotten moved out into the infrared. And we really want to be able to see those same diagnostics out for those early galaxies. And unfortunately, working in the infrared is really technically very challenging. And the reason is quite mundane. It's that all the objects at room temperature glow in the infrared. So this is why when you go to a science museum, you see the thermal cameras, and you can see the difference in the temperature between your face and your clothes is because we're all glowing in the infrared. So we're glowing, the table's glowing, and the telescope is glowing, and the atmosphere is glowing. And so when you're trying to study early galaxies in the infrared, you're looking for these tiny, tiny heat sources against the roaring furnace of your telescope and the atmosphere. So it's really hard. And so why is JWST going to be so amazing for the study of these galaxies? So the first is that it's cold. So the Hubble Space Telescope and many other satellites operate around room temperature because it's too hard to build them and test them cryogenically on the ground. So the Hubble takes the energy from its solar panels and heats itself up so that the mirror is at the same temperature as it was made on the ground. And the James Webb Space Telescope instead has actually been built to operate at 40 degrees above absolute zero, so 40 Kelvin. So the whole telescope is cold. And that means that all of its glow has been shifted out even further, even into longer wavelengths, which will make it actually not glowing at the critical wavelengths around 1 to 5 microns. So that's perfect. And the second reason, of course, is that it's big. And size here really does matter. So the power of a space telescope goes, when you're talking about faint, small objects, goes as the 4th power of the diameter of the telescope. So you get 2 because of the area of the telescope. You're just collecting more light, 2 powers. And you get 2 more powers because with a bigger telescope, you can make a sharper image. And so the previous mission at these wavelengths was the Spitzer Space Telescope. And that was, it was launched in 2001. It did amazing things. It was this little telescope. It was able to detect galaxies on the other side of the universe. And it could do these great things because the backgrounds in space at these wavelengths were so low, and these galaxies are preferentially glowing in the infrared, so the contrast was actually relatively good. But Spitzer was only an 85 centimeter telescope, so about that big. JWST is 6.5 meters across, 20 feet across. So it's going to be 3,000 times faster. So 3,000 is a big number, like that really helps. So things that Spitzer could do in 100 hours, JWST can do in 2 minutes. So we'll be able to get tremendously fainter. And the last reason here is that it has great instruments. So it's wonderful to collect all the light, but you actually have to be able to detect it well and do clever things with the light that you detect. So JWST has a very aggressive, useful suite of instruments that can image in many different band passes, and that can take the light of 200 objects simultaneously and split them up into a rainbow of infrared colors. So it's going to be just a really diagnostic thing for that. It's an extremely complex and technologically advanced telescope. Many aspects of it just weren't possible 30 years ago. We've really learned an enormous amount about how to build telescopes of this form. The entire telescope is too big to fit in a rocket when it's unfolded, so it actually launches in a folded up configuration and unfolds itself, and actually can phase all the mirrors into one large mirror in space. So it's just extremely impressive that way. Everything has to be lightweighted. Everything has to work at cryogenic temperatures. Everything has to survive going from room temperature compressing down to cryogenic temperatures, right? Things change their size when they change, and everything has to be able to do all that and survive launch, which means you have to build something that is flexible enough to survive compression and yet rigid enough to survive being shaken at many, many times the force of gravity. So it's really remarkable that way. And so astronomers are really looking forward to the arrival of James Webb Space Telescope. There have been many questions in galaxy evolution and other fields of astronomy where, for the past 15 years, the answer has been, we don't know, we're going to have to wait for a large infrared space telescope, and finally it's about to arrive. So launch is scheduled for October 2018, and I hope you will be reading about it from Ken when science operations start in 2019.
So as David mentioned, I was hoping not to be here. That's because I was hoping to be on a plane leaving Newark in about 2 hours to Beijing for a space exploration conference. And as you might imagine, getting a journalist into China isn't trivial. So not only did I supposed to get an invitation from the conference organizers, the conference organizers had to get something called a visa notification letter from part of the government that was, quote, their duly authorized unit. That never showed up, so I couldn't get my visa, and instead I'm here, which is great. But it also means I don't have anything prepared, and so I've been listening to everyone else and realizing they've talked about most of the things I write about. So instead, I'll say a few words about what I was hoping to learn in the next week, and in China, and then a few words about Luxembourg. So, for most people, space hasn't been really exciting since the 60s, or at least for the general public, when there was a race between the US and the Soviet Union to get to the moon. That's where the astronauts were actually heroes. You actually knew the names of the people who were going on these rockets. And of course, everyone remembers Neil Armstrong and Buzz Aldrin. And honestly, is there anyone here who can name an astronaut in space right now? Can anyone name an astronaut? So obviously, it hasn't been that sort of attention since then. So China is an interesting latecomer to the space race. So the US and the Soviet Union launched their first astronauts in the 60s. Obviously, we got to the moon in 1969. China is the third country to do these, to get an astronaut to space. They've only done it relatively recently, about a decade ago. So the program is still relatively small and relatively far back compared to where NASA is. But it's quite possibly the most promising and interesting space program that you don't know about. So what they've done since then, they've launched the first astronaut who went into orbit, basically did what John Glenn had done in the 60s. They've then launched a spacecraft of 2 people. They launched a small space station. They docked with it. They launched a larger space station. They set the crew up there for 30 days, came back. So they're taking all these incremental steps to catch up to where NASA is now. And next year, they're going to launch the first core component of what is going to be a larger space station. It's not going to be as big as the International Space Station, but it's going to be large enough to hold several people. they've basically announced that they have an agreement with the United Nations that this space station will be open to all countries in the UN. So if you're a country in Africa, you can send an astronaut there. And it's kind of interesting because the International Space Station right now is scheduled to be deorbited in 2024. The Chinese space station is supposed to be complete in 2022. So in 10 years from now, it may be China has an International Space Station, not NASA. And they also say that their goal is to land Chinese astronauts on the moon in about 10 years. It doesn't sound very impressive since Elon Musk says he wants to go to Mars in 10 years. But what's interesting about the Chinese so far, they've been fairly modest about what they said they're going to do, and they've actually been hitting the marks of what they're saying they're going to do when they're going to do it. So, and getting to the moon in 10 years is something it seems like they're going to do. And then they said eventually they want to go to Mars. So it's something that's quite reasonable. And what's interesting is that in contrast to what everyone else has said, China basically has an old-style government space program. And that actually has advantages in some ways compared to how we do it in this country. So NASA has much more money. It has much more grandiose plans. But if you follow the space program for too long, like I've been writing about NASA for 10 years now, the US doesn't have a long enough attention span. So if you recall, George W. Bush announced a plan to go to the moon and then Mars. Then President Obama was elected. He basically set up a big commission to look at it. He said, now we've been to the moon, we don't want to go there anymore. Then he said, our big goal is going to go to Mars, and then we'll stop by an asteroid along the way. That turned out to be too difficult, so then they said that they were going to capture a small asteroid and bring it back to the moon, and then send astronauts there to go take a look at it. No one got too excited about that. That has now been canceled in the first budget proposed by President Trump, and now the idea is this lunar deep space gateway, which is still in its preliminary stages. That also doesn't sound too exciting. So it's not clear if that also will get the funding. So by contrast, the Chinese have this program where they've said exactly which step they're going to do. They have a one-party system, so their leaders aren't going to change their mind in 4 years or 8 years, and so the people working on it know that they will actually get to do what they're planning to do. So it'll be interesting to see. So they're sort of doing the slow and steady government race, and how that will do with our sort of faster, more expensive, but sort of start and stop program, and how the ambitious plans of Elon Musk and Jeff Bezos play out. And I guess I'll throw in one other caveat, that this could be exciting, except with these commercial startups, but that's happened before, and also these public-private partnerships with the government. So in the late 1990s, there was this program between Boeing, Lockheed Martin, and the Air Force called the EELV. What was the E again?
Expendable, expanded.
Large vehicles. So basically, the government was looking for cheaper ways to launch its spy satellites. And the Air Force basically financed some money with both Boeing and Lockheed to build new versions of their launchers. The idea was that this would be cheaper, it would be fixed cost, and then that would save the Air Force money, and this is going to finance this great new commercial industry. And at the same time, there was companies like Iridium that was going to launch hundreds of new satellites for communications. Now, and there was also all these new startups that were also looking to get into this market. Now, what happened was that satellites never showed up. Those companies that were planning to launch these communication constellations went bankrupt. the new launch companies went bankrupt. In fact, the only company survived was actually Orbital Sciences from this period. And what happened that Boeing and Lockheed Martin lost literally billions of dollars, and they were so unprofitable that they basically came to an agreement with the government that they were going to form a monopoly called United Launch Alliance, which still exists, and that's still the primary launcher for spy satellites. And maybe this time it's going to be different. It feels like there's more companies and it's more variety of businesses that look like they could be enabled by SpaceX and Blue Origin, but it's still not something definite. Now, I mentioned I was going to talk about Luxembourg. So Luxembourg is actually you don't think about Luxembourg in terms of space. Most people have trouble finding it on the map. It's a small country, it's next to Belgium. It's not the one that has the stamps. But what's interesting is that Luxembourg a couple years ago, it announced that it was investing $28 million to mine asteroids. Now, it wasn't actually going to start its own program, but it was going to invest in companies that were looking to do this. And most of them are in the US. There's a company called Planetary Resources in Seattle, and another one called Deep Space Industries outside San Francisco, Silicon Valley. And you think about that, kind of sounds crazy, right? That you're going to go fly out thousands of miles to a rock, try to dig up some platinum and bring it back to Earth. And that's not going to happen anytime too soon. But if you go and talk to companies, that's not what they're looking to do in the short run. They're looking to develop the robotic technology to get to an asteroid, but they actually have other plans first. So Planetary Resources, its first plan is to go out there and get water from an asteroid and bring it back to Earth orbit, and then that water can be split up into hydrogen and oxygen. And that's actually kind of useful for astronauts in orbit. You need oxygen and hydrogen, and the oxygen are propellants for rockets. And so you realize there actually could be a business case there. And again, they're funded by billionaires, so they actually have money as well. So Luxembourg has basically said, we want in on this as well. So they've invested, I believe, about $10 million in Planetary Resources. Planetary Resources is going to open up a European office in Luxembourg. And this could be, and Luxembourg actually has a track record. So in the 80s, they invested they started up a communications company called SES, which is now the dominant communications company, and that's a Luxembourg company. So the Crown Prince of Luxembourg actually went on a tour of these companies 2 months ago, and I actually got to follow him around. And so it's interesting when this other country is also looking to get into space now that you actually don't think about as a major space power, and that they see that there's actually potentially money to be made in the coming decades. And the other thing that's interesting is that now all of a sudden there's renewed focus on this treaty known as the Outer Space Treaty that was signed in 1967. This is back in the era where, of course, it's the US and the Soviet Union dominating space. And clearly the thinking was there is that there's going to be nations leading the exploration of space, and that perhaps the companies would be sort of following up later. And there's Article 6 of the treaty. So US actually the Soviet Union wanted to say that only nations would be allowed to do things in space. The US said, no way, we want there to be the chance of commercial enterprise in space as well. So US insisted on this article, which says, so it specifically talks about non-governmental organizations, and it says that these private companies are allowed to do things in space, but that the nation that they're based in must authorize and supervise these activities. And that's actually, and it doesn't go into much more detail. So now all of a sudden there's debate both internationally and in Congress about what does that mean and what is the requirements of authorizing and supervising activities in space. So there was actually a congressional hearing chaired by Ted Cruz. Is he here? He is. So looking at it, and there was lawyers there in one part of the panel, and then there was 3 companies in a second panel talking about it. And it was actually a really fascinating panel, if you think about it. It's about treaties and government regulations. And it was fascinating. Especially since the lawyers was basically, or 2 of the 3 lawyers on the first panel were basically arguing, you can basically ignore the treaty. Just go do what you want to do and let the companies do whatever they want to do, and we'll go back, and if they cause any problems, we'll go back and do some regulations as necessary. And they had arguments for why the treaty was flexible enough for them to do that. And then the companies would basically say, no, we actually want some level of regulation because, one, our investors want the certainty that if we go get this water or platinum or other materials off this asteroid, bring it back to Earth, that we're going to be able to sell it. Otherwise, it's not a very good business. And 2, that they want the U.S. to have some standards so that of a company that's based, in Saudi Arabia or in China goes off and do things in space, that they will also have sort of the same standards and rules, and that the companies won't interfere with each other, or that China won't go interfere with a U.S. company on an asteroid. And so they sort of want there to be some normalization of behavior in space. And so it's interesting. Possibilities out there. It's still not clear what's going to happen or what's going to be exciting, but I'm really hoping that's something that I'll be worried about in the coming years. So I'll give it back to David.
Thanks. So let's first thank all the panelists for their contributions. And I'd like to now open this up to questions from the audience. So back, Mike.
A question for Michael about the satellite research. You used the word autonomous. Do you mean there are going to be units that go up into space without any persons watching them and twiddling knobs and other joysticks and do the repairs? Or do you mean a person is going to be looking and monitor and using joysticks and actually telling the robot now turn the knob, now put in the fuel?
Great, it's an excellent question. So initially, the second paradigm that you talked about, which is an astronaut with joysticks or someone, a technician on the ground, that was done with Orbital Express to a certain point in 2007. The goal of these new demonstrations is for them to be fully autonomous. At the beginning, there'll be a human supervisor with a stop button. Obviously, if there's damage or something's not working right, to stop the process. But the goal is to make it autonomous, and it's for 2 reasons. One is it'll be a much more powerful system if it can be autonomous, and second is if we want to do the same thing and we're orbiting Mars, if we're going out on a repair mission to repair Mars Reconnaissance Orbiter or put a new camera up there, it's 20 minutes one-way light travel time back and forth. So we need that technology to be autonomous. So the objective is to make us fully autonomous.
One of the things that's changed remarkably in autonomous vehicles is who the players are. So 20 years ago, we just look at basic research in autonomous operations, it was 95% NASA. Now with all this work on self-driving cars and things of that sort, and all the big drones, NASA's probably 5% of the basic research. So there's just a lot of, I think, possibility there.
I know we get accretion minimal from meteor showers and things like that, but how much mining of material and bringing it back to Earth is going to have an impact on Earth orbit, the mass of the planet? You think it's going to be minor at first, but if this really catches on and people start bringing
this small.
Yeah, I mean, I recall,
You can think of it being balanced by, well, anything we send off into space makes the Earth less massive. And I think, there are changes that we might worry about with the Earth. The carbon dioxide we're putting up in the atmosphere is having a pretty profound effect. The mass we're taking off in weight in rockets and bringing back in samples is tiny.
yeah, I think the amount of platinum that's ever been mined over the history of the planet, I think fits in this room.
Over there?
I wonder if anybody has given thought to just cleaning up, getting rid of old satellites and things like that as we, the golden or platinum age may be coming, but if we have so many things in orbit, it becomes an obstacle for us. And there would be good business in literally having a vacuum cleaner.
A vacuum cleaner in the vacuum of space.
So the space debris problem is a problem particularly in low Earth orbit, and particularly because of not the satellites we send up, but the pieces that fall apart when satellites launch. And there was particular concern when the Chinese decided to blow up a satellite to demonstrate that they could do it. And produce so much debris that there's worry about a runaway effect. That if you
The
have
movie Gravity was kind of like a...
Right, the movie Gravity showed this happening on a very rapid time scale. It's not going to happen that quickly. But you have a piece of debris hit a satellite. The satellite splits into lots of pieces. It's basically like a nuclear chain reaction. Those pieces then hit another satellite. And it's possible that low Earth orbit becomes unusable. Now, one thing that helps us is the sun cycle. Is when the sun goes through its 11-year cycle, it heats up the atmosphere, and that cleans up low Earth orbit. So that helps somewhat. And I think this is something where there's a lot of people understanding the risk, and I think spacefaring nations are now much more careful about not flying junk, so there's not so much to clean up. But I haven't heard of any cleanup proposals.
No, there have been some ideas that have been put forward, but I would say that I think the problem is going to get worse before it gets better. We have lots of CubeSats going up. These are very small satellites being developed by universities and other companies, and they're putting them up in great numbers. We have Webb, which is a commercial venture, putting up 700, and that's not in real. That's about 1,000 kilometers, and then orbit. And then we have Musk is talking about putting up thousands of spacecraft, and these are up in between 1,000 and 1,500 kilometers, and these will increase the risk. And as David said, once you get collisions starting, then you get lots more particles going on. So this is a major issue that I see facing us in the next 5 to 10 years.
There are some ideas and demonstrations in Europe, companies here. There's a lot of small companies looking at innovative ways to clean up space junk, for lack of a better term. The big problem that I see is who pays? If you develop a really cool vacuum cleaner to clean the debris up, who's going to pay for your service? It's a real good question. So who's the customer? You could say, well, it benefits everyone, but who do you send the invoice to to get paid? So there needs to be some, so I see it as a technological problem, and then also, there needs to be some sort of entity that, would take responsibility to pay for this, because I agree, this is going to be a problem that's going to get worse and worse, but, who's going to pay? Somebody has to pay for it to be done.
1-800 got junk.
What's the estimated mission time for a mission to Mars? I seem to recall reading that it would be over a lifetime.
You mean a human mission to Mars?
Human mission.
Because on the robotic, we can get there as fast as 5 or 6 months, or you might take a year, or in some cases even 2 years to get there. It depends upon the trajectory. But if you're talking about how long it's going to take to get humans to Mars, I think that depends whether the nations work together to make it happen. And I believe it was Michael was talking about the fact that we need to have a continuous commitment on the part of the United States here, the governments, to make that happen. Going from an interest in Mars and maybe back to the moon and back to Mars will not enable us ever to get to Mars. We have to have a long duration, a long commitment to get out there. And then it's just speculation on how much money you're going to put into it and how much resources you're going to put into it. I don't know, does anybody here want to speculate?
Well, usually the two answers are 20 years or we should have been there already.
Right. But to make sure we get it
I think
clear
you
on the
meant travel
question,
time.
it's not 20 years of travel
No.
time.
Yeah.
Oh, I'm sorry.
It's the travel time
Now,
is really
I
the
think
same.
about 6 months.
Yeah, we're going to do travel as quickly as possible. We'll get out there. 6 months is about the best you can do on a Holman transfer. And then you'll spend maybe a year there waiting for the planets to realign, and then another 6 months or 8 months to come back. I'm sorry.
Thank you.
Yep.
let me just thank the panel. This is fascinating stuff to me. I just retired, and I am fascinated by this. If you were to recommend, I'm closest to Ann Arbor, University of Michigan. Is there a course out there, the Cosmos,